Alright, I'm just gonna cover the last, well, not the last, the second last data type that's within the EMO that I've so far seen. What I'm gonna do is I'm gonna delete the stuff around it just to isolate it so that we don't get lose focus. So of course this is just a sub file within the EMO, but we're just gonna isolate it. All right, so we don't have to think about other crap that's inside. Where is this stuff? Okay, so this is vertex information. We're going to delete this. We don't need this information. Okay. So that thing that I deleted was the third and the last block in the EMO file. This is the stuff I said I didn't really understand why they had it, because the vertex buffers are defined in the object blocks, the EMG files, and then they have a big vertex buffer that's over, bigger than the whole size of the file. Like, not sure what it is. I'll have to study it, and if I do understand it, I'll append the video. But I'll just delete that. So this midsection in the file is 100% all skeleton data, and it'll just review that. Save this as SKL. Right on. So this is our skeleton file. Now the header here is pretty simple. We got to count. That's how many bones we got. Okay, 11. I forget what that means. Let's go have a look at my function. All right. Oh, okay. So this is data count. So this is telling us how many offsets. So it's saying 11 offsets. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this data here is how many data blocks we have. So it's basically saying, okay, our skeleton contains 217 bones, and then we have 11 data blocks. And then these are the offsets to each data block. So you would read each offset. If it's 0, the data block is not present or invalid, or whatever you want to call it. So our first data block is the 40, and that would offset from, I suppose, the beginning of the file. So, or this section rather. So that would be 40, the address here, which brings us here. And that's the beginning of that. Now I guess this is kind of weird because it says 11. It terminates here, and then we're given this other data section, which looks different here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Not exactly sure what this data section is, really. Is it a float? Okay, so I'm going to note, yeah, there is one huge unknown right here. Okay, this stuff I'm comfortable with. These are just defined data sections, and then after that, these are not offsets at all. They're just look like gibberish. But they must have to do with the skeleton. Now, could be indices. Might not be. Not gonna risk it. Not sure what that is. Complete unknown. If I have more files, I'd probably study it, but I don't know. All right, next we have these matrices. So this section here is going to be your matrices, and your matrices is simple stuff. So if I remember, this first thing here is your parent ID. Second one is your child ID. So you have 1, 2, 3, 4 children, I believe, and then preceding that, I think it's just float information. So we have float 1, float 2. Oh no, that's float 1. Oh, so this whole block here is pertaining to that. So let me just check real quick here. Child, unknown. Great. All right, so this stuff is all related to indices. So parent ID, child 1, child 2, 23, 4. Then this stuff is just unknown, apparently. So we have 1, 2, 3 more indices. No idea what they are. So this is totally unknown. Okay. Now this is your matrix information. All right, which is going to be right up to here. All right, so yeah, so you got your typical 4x4 matrix, your your cosine 1, 2, 3, scalar 1, 2, 3, scalar 1, 2, 3, scalar. You get your position x, y, z, scalar. Okay, that's pretty simple. And then you're going to loop this based off your count at the top, which was 217. And then that would bring you to the end of whatever that went to. Next, you got the next data section, which is this one. Which brings you to here. Again, you're going to read each long for your count, which was 217. These, I believe, are the string table. So if we go to the offset of that first offset there that's given to us, it brings us to a string. So this second data block here is bringing us to the bone names. So it's actually bringing to an offset table, which then offsets to the names, to the string table. The next one is invalid. We don't know what it is. The next one's invalid. We don't know what it is. And the next one is... Alright, this one I'm going to admit I don't know. You read it in sections of 1, 2, 3, 4, 5, 6, 7, 8. So 8 bytes. It appears, because there's a short here, it's probably defined in 4 shorts. So 1, 2, 3, 4 indices are given to you. No idea what they are. They're all consistent. Doesn't seem like it matters at all. There's a different data section. All right. So that one we don't really know. Next one. All right. This one again is, which seems to be another matrix system. I'm not sure why it's here. You get another 4x4 matrix. That's 1, 2, 3, 4. You can tell because the scalar value on the position is always going to be 1. So you're going to just loop 64 bytes for each bone. And these matrices, I'm not even sure what they are. Usually when they store matrices, they store a world one and a local one. I think this might be the world one. Because the matrix that we get in the other data type, that's the one I use. That one's actually relative. So you would just you would multiply its position or its translation by its parent. As those ones that are world, you don't do anything. You just pop them there. Anyway, where was I? Okay, so this section we were seeing. Then we got this section. This brings me to a small little map at the end. Yeah, I've seen this before. It's a fixed set of characters that are 256 bytes, I think. This one I think is short, so you're actually only getting 128 entries. Not entirely sure. What I think it is it's a bone map or a skeleton map. So, like in video games, say you have a animation skeleton, like a basic animation skeleton that's just a normal T-pose skeleton that can punch and shit. This will allow you to map that on. So, like, you might have a base skeleton where the head is index 10. So your bone index might be 20. If you want to map that to the base skeleton, you say 20 is actually 10. But I'm not sure how this is actually working here. So this I would consider to be involved with the bone data, but not entirely sure what it is until I can test it or debug that in the game. But that's what that is. All right. And then I think that's it for the data sections. If we go back up here, everything else is just blank. So they're not being defined. So we don't know what they are yet. So yeah, that's the skeleton data section. Couple unknowns. Obviously, the block down here, no freaking idea. We also have the extra world matrix right there, which isn't understood properly. Then we have this weird list of 4 bone indices. And then we have that weird thing in the middle there. So bones, not entirely sure on. If you're writing your own file, it would probably just be best to append or remap this data onto a mesh source that you're going to bring in rather than rewriting it. Props to you if you can understand the rest of this. I have no idea. Alright, so that's the last data section. There is another data section in the EMO, of course. There's nothing I can say about it. It's in the middle of the file somewhere, about here. And it's just vertex information, from what I can tell. I'll frig around with it some more to see if I can actually understand it. What's this? Split. But yeah, I'm not entirely sure. Not yet. Yeah, I don't know. Alright. So yeah, that's the EMO format. That's how you get an object in. I wrote this Mac script. I'm going to combine it with another Mac script. I wrote this up. It's basically to load up the EMM file, which is basically when you import the model, it's going to look like this. What I have here. All right. Now you can tell that the textures are all blue, right? And that's just because that's how they were. I'm not exactly sure. Here, there. They are. You have your typical diffuse textures, but then you have these like limey blue ones, all right, and something like that. So if you go to the first one, you can actually get an idea of what's the reality of this. Is a mixture of maps. You have your typical diffuse that's inside, all right, and then you have these other ones that don't make sense. So really, what they've done is, I don't know if I can hide different maps. Yeah. So what they've done is they've oh, I can just do that actively. That's cool. So yeah, what they've done is they've put in different channels in the maps that are masking the map. So you're basically telling your engine, okay, at this black spot, render blue, okay, onto this map. So you're going to multiply your red channel with the other channels. So it's actually kind of interesting. So there's a material system there that isn't completely understood. So because the material information tells you which textures to use, but doesn't tell you how to actually make them. So yeah, we get this, but to get from this to like, what's the actual thing look like? Like this, I have no idea. All right, so I'm still trying to look into that. But yeah, this is where I'm at so far. The EMM is supposed to read the material file and kind of do that up for me, but it's not working out. So yeah, I'll put this in another video, but this is just a video on the format itself. Anyway, hopefully you got something out of that. All right, talk to you later.